Okay, so we are doing notes for worksheet 11. We are talking about composite functions. So it says composite function is the term for when a sequence of transformations take place. So if we reflect point A over the x-axis, we get A prime. And then if we rotate A prime 90 degrees about the origin, we get A double prime. So I know mine kind of printed weird, but it's A double prime. The first thing to notice is that as we perform transformations in a succession, we continue to label with the primes to show who is the preimage of who. A is the preimage of A prime is the preimage of A double prime, and A double prime would be the preimage of A triple prime, and so on. And then it says, does it matter what order we do them in? So we're going to be talking about like just two different transformations mixed together to be called a composite function. And we're trying to see if the reflection, like if it matters what order we do them in. So what it says is we have a translation of 3, negative 5, followed by a reflection over the x-axis. And then here it just flips them. And it does a reflection over the y-axis and a translation of 3, negative 5. So we're trying to see if they end up at the same spot. So we start with A here, and then A prime and A double prime. So what they did was they translated, then reflected. Here, they reflected and then translated. As you can see, the A double prime does not end up in the same place. So order does matter. Order does matter. So now we're going to try, and we say, notice that the two composite transformations result in different locations. So now we're going to try some on our own, and we're going to see if they land on the same spot. So 90 degrees about O, which is the origin, and then a translation of 3, negative 5. So we're going to go ahead and rotate that 90 degrees. So if I'm over 1, 2, 3, I'm going to go down, so to negative 8 up 2 for A prime, and then B prime over 1, 2, 3, 5, 6, 7, over 6 up 7, B prime, and then C 2, 7. I connect those, with a straighter line than that. And then I have to move it to the right 3 and down 5. So to the right 1, 2, 3, down 1, 2, 3, 4, 5. And then 1, 2, 3, 1, 2, 3, 5. And I have moved that, and that is my double prime. So that's what happens when we do a rotation and then a translation. Now we're going to rotate and then now we're going to translate and then do a rotation. So I'm going to move 1, 2, 3, down 1, 2, 3, 4, 5, A prime, 1, 2, 3, 1, 2, 3, 4, 5, B prime, and C prime. And then at this point, you're probably starting to think, don't think they're going to land in the same spot. But who knows? We now have to take this and do a 90-degree rotation. So I'm going to take it again, and I'm going to go over 10, over 2. So I'm going to go over, that's 3, up 10. Give me C double prime. And B is 10, 1, so it's going to be negative 1, 10. And A is 5, 3, so it would be negative 3, 5. And remember, if we're doing a 90-degree rotation, what happens with our points is they flip and one becomes negative. So like if this is 5, 3, I'll show you A prime is 5, 3, then A double prime would be negative 3, 5. So that's how I found those points again. Did they land in the same spot? No. So why do we think it alters it? Like, why does it change? So I'm going to give you seconds to think. And then we're going to say, it says, so why do you think order alters the resultant location of A double prime, B double prime, and C double prime? So in this one, our reflection changed it because the distance of the line of reflection. And then here it's also the rotation. So we're just going to stay down here and say the distance from the line of reflection is altered by the order they are done in. And it's also, it's the line of reflection or the point of rotation. So either of those things could affect where your shape ends up. And then our last page of these notes. So then it's just talking about like the mathematically correct way to write composite functions. So we would have the translation, negative 3, 5, and the reflection of R was the reflection over the y-axis. And you actually read it backwards. So like the thing that you would do first is actually what comes second. So work from the inside out. So reflection over the y-axis happens first. Then this happens second, and then you get the result. Rotation is big R over our center of rotation, and then the amount of degrees, and then you get the result. When you say it in English, it says a rotation of 270 degrees about the origin, followed by a translation of 9, negative 3. When we write it as math notation, we put the second one first, and then we have this little circle that just means that there's another transformation happening. And then we do the rotation, and then we say, what are we doing the transformation to? And then what is our end goal? And then we have a reflection over the x-axis followed by a rotation of 180 degrees about the origin. So again, we're going to do that rotation first. Then we've got the reflection. What are we doing it to? What is our end goal? So then we're going to try some on our own. Which transformation would you perform first? So you have either the rotation of 180 degrees, translation of 3, negative 4. And it's just asking you which one you would do first, and you would technically do the second one. Sorry, I dropped my pen there. So it would be this one. And then here, reflection over x-axis, reflection over y equals x. You do the one that's second first. So everyone's written second first. And then it says create your own here. Given ABC, translate it, and then follow it by a reflection over the x-axis. So we'll actually write the x-axis. So little r, x-axis. Oops, and I went over. And then t, negative 5, 3. And then given triangle ABC, rotate it, and then follow it by a translation. So we'll say the translation first, and then a rotation about the origin at 73 degrees. So that is it.